Hello, this is my second video showing off the NPC I made to beat Steven's obstacle course. The first one I made when I thought I had finished, but upon further testing, I realized that there was more things I could do to make it more consistent, and some of the numbers I put in just weren't working anymore. I don't know why, didn't touch anything, but sometimes Unreal is like that. So anyway, fixed a whole bunch of stuff. Everything's works a little differently now, so I thought I'd make a new video. So I'm just gonna start. I have my blueprint, my character, which does have a little thing in it where it has a frame rate value, which I am just getting by dividing the delta time, dividing one by the delta time. This will come in handy later, but for now it's not really used for anything. Then we can look in the behavior tree. So in my behavior tree, let me just make some room here. I got a selector going into a selector. Technically, I guess I don't need the second selector, but who's to say I don't need it? So it starts over here with the Blackboard base condition to check if I have reached the first checkpoint. So basically, this point achieve Blackboard key is an actor Blackboard key like the rest, but it's set using, actually, I think it's set in this one. Yeah, in this EQS query. EQS Olivier close find safe zone, which, or actually, it's actually the arrived at zone one that I'm thinking of. Which checks a basically just a small radius to see if I've arrived at any BP safe zones, and if I have, it sets itself, and then that's basically how we start this whole thing off, is by we check if that is set, and if it's set, that means I've arrived at the first safe zone, so then I can move into the next stage of the behavior, which would be the Indiana Jones rolling ball stage. But anyway, so we check if that's not set. If it's not set, I made my own decorator called Stuck on Spinner, which I can open up here. It's a little messy right now. I might fix that up after making the video. So we get the basically the whole point of this is to figure out the delta of how far the character has moved. So I get the last position over here, and I check if the character has moved recently, or well, I run this every time the character, every time it's called. So I get the character's position and their last position. I compare them. I compare the distance between them. I get the delta from that, and if it is smaller than 4, then in the behavior tree, essentially this returns false. And if it's greater than 4, it returns true. And if it returns false, that means that this fails, which means we go to the next thing, which is this EQS query, which is the one that checks if we have arrived at a safe zone. So it checks that. Oh, I'll just close that for now. It checks that, and then if that doesn't work, we go through here where it uses the stuck on spinner thing again, but it uses it in reverse. Basically to check if the player has no velocity. That's what it checks. And then I set a time limit on that because I tell it to find the start using this EQS query, which is EQS find start. So it's very basic find actor of class EQS, where it finds blueprint grid, which is the start location for all the actors, and then we just do a move to, but it only takes a second, so it basically nudges it back if it's not moving at all. But if it is moving a little bit, then we'll wait 1.1 seconds. I just found that to be optimal for my NPC, and then loop it all back over again. I also have in my decorator this little thing at the top, which basically just waits 1 second essentially, because I take the frame rate. This is where I use that frame rate thing from earlier. I take it, and as long as this counter is less than the frame rate, the character can just move without having to have velocity before, or else it kind of bugs out and just stays at the start. So that's how all of that works. So we do this until we get to the first safe zone that the character is targeting, in which case the one condition, this one right here, point achieved, is set, which means we can now go into here, because this one checks if point achieved is set and checks if target actor set. It checks both because it needs both to be set. And this one has a 2-second time limit. Again, arbitrary number, but I found it to be optimal, because it doesn't actually take that long for the character to get from one safe zone to another, but I found that the character was waiting there for longer than it needed to. Then I have this BTT, which I can't remember what that acronym stands for right now, but I have it. And that's basically where the rest of my control flow is. So we start over here by basically we get all the safe zones, and we find all the safe zones that are like in front of the player, so that's not going side to side and back and forth essentially. And then out of those we find the nearest one, and then that is our nearest safe zone. Then we find the nearest ball in front of the player, and essentially we're just checking the distance from the player to the nearest ball to tell it if it can go or not, because if the ball's too close, then it's just going to roll over the player even if there is a valid path. This one was a little bit tricky because the ball starts, I'm going to just show here. So when the ball starts here, it starts with no velocity, and as it rolls down, it gets faster. So it's not a consistent amount of time between each one of these that you need. Like, to get from here to here, you have a lot of time, but to get from this first one to the second one, you don't have quite as much time. And so I have a little bit of crazy math here, which lets me scale based on the amount of valid safe zones. So I have the valid safe zones, which if you're here, it'll be equal to 9, because there are 9 safe zones in front of the player's current position. So you get 9, you divide it by 3 to get 3, or if it's 6, you divide it by 3 to get 2, so on. Then I get the power of 2 of that number, and I multiply it by 100, and I add 1,550 to it. That number is special because it makes sure the player won't dash in front of the ball when it's at the bottom, but it does add a little time save near the top, which I'll demonstrate. I'm going to show the player moving after I explain this. So then, if the closest ball distance is within the range that we want it to be, we can keep going. If it's not, we just fail the execution of the thing. Then this is just to go to the nearest safe zone, which I just do by getting all the safe zones and finding the nearest actor to the player. And if there are no safe zones, or rather, basically, if the safe zones are equal to 0, that means that this will return true because the length is equal to 0. And we'll just go to the finish line. I also needed to add that same thing here, where basically if the player isn't at a safe zone, then this key isn't set because it's going to be set to this thing. So then it gets confused and it can't cast. So if the cast fails, that means that we're already heading for the finish line. So I just tell it to keep heading for the finish line, because I was having trouble with that before. So that is everything. That's how it works, and I can demonstrate it right here. So here's our player. I'm gonna press play. So it'll go here. See how it met some resistance there, so it just decided to stop moving. That is what I found to be the most efficient way to do it. So now it'll go here and it'll wait until the balls pass it. Then it'll go to the second one and the third one. So that's why that number, the 1,550, was so important, because it allows it to somehow get from this one to this one very quickly, which I think could help in the race aspect of this whole thing. I could make the number larger and then it would be safer, but I haven't had it fail with that number yet, and so I think it's safe. I think it just works every time. And yeah, that's basically how I did my AI. Thank you for watching.